No, I lost. So if you want to run it, okay, where was I? Python 2 is what's installed by default on the Mac. When you install Python 3, it keeps using Python 2 underneath it all. But then when you run idle and you run your programs from within idle, it launches Python 3. Well, what if you want to run a program from the terminal, from the command shell on the Mac, the bash shell? Well, you type Python 3. That's how you run it. On Linux, I don't believe you have to specify Python 3. I think you just type Python and it goes. You can always find out what version it is. Or so I say. Let's make sure that this is true. You just type in Python, it tells you which version it is. This is running 3.7. Now on Windows, if you can't run Python after you launch the command prompt, fastest way to fix it is just to uninstall it and reinstall it. There's an option down there at the bottom on the first install screen that says set up the path. You're going to want to click that, and then you'll be able to reinstall it, and then you'll be able to, it's as easy as that. Okay, so something else in there that I want you to know how to do on Windows. I don't know how to do this on the Mac. On the Mac, if you're going to be changing directories and stuff around like that, you're going to have to get pretty good at it on your own. But say I want to run the command prompt inside my scripting directory. What I do is I maneuver to the scripting directory that I want. I highlight all that with a click. I backspace and I type CMD. And boom, I've got a command prompt that's already initialized to the directory where I want it. Why is that good? Because otherwise, if I run the command prompt any other way, including hitting Windows R and typing in CMD or clicking on an icon somewhere, it puts me in the wrong directory. And by wrong directory, I mean it puts me in a default directory. And I have to CD several times to get into it. So it's kind of nice to be able to go directly to the directory that you want. And then if I do a dir star.py, I'll see all the scripts that are in that directory. And I can run one of them if I want to, python a.py. Well, all that one printed out was main method. Whatever. I don't remember what we were trying to prove there. Topic I wanted to hit was how to pull out command line arguments. And I forgot to bring up my sheet about that, so I may leave that alone. What is a command line argument? A command line argument is when you type in something from a command line to get a program running, but then you type in additional commands. They're called arguments, just like the arguments that fill the parameters when we write our own. So Python \question is an argument that displays all the options for Python. Okay. You know, dir/od orders everything in that program by date. And dir is a program just like any other, so it accepted a command line argument. And if you do dir star.py/od, we have given it two command line arguments. The first one being the file path skeleton, the wildcard, and then the second one telling it to sort by date. And so the people who wrote the dir program, Microsoft, have written it in such a way that if you don't call it with anything after dir, it runs in one fashion, but you can also specify other things, including the wildcard or the file name that you're looking for, and some other commands. If you do dir \question, it tells you all the different commands you can do. I have complained about that and not got no response. Okay. So that's how you run it from the Macintosh terminal to launch CMD in a folder. Go to that folder, click in the address bar, backspace, and type CMD. If Python from the command prompt doesn't work on Windows, just uninstall and reinstall, clicking the option to set the path. Can't type. All right, I don't quite remember how far in Chapter 4 we got, but I know we were talking in Chapter 4. We had hit the section about generating random numbers, and I believe we had talked about the math library, so it's probably around here. Either we got all the way through it or we stopped here. So there's a little bit more that I want to do on the topic of functions before we get through it. It may not be clear why it is worth the trouble to divide programs into functions. Several reasons. Creating a new function gives you an opportunity to name a group of statements which makes your program easier to read, understand, and debug. Like if you have a function, a module called calculate pay rate, and then you have several lines of code there, then in your main code where it calls calculate pay rate, you know what it's doing. You don't need to go in and figure out the details. You know what it's doing. So functions can make a program smaller by eliminating repetitive code. Later, if you make a change, you only have to make it in one place. So you're calculating gravity, but you calculate gravity in 17 different times in your program for some reason. If you stick that in a function, then the equation for calculating gravity is just contained in one place. So if it turned out you made a mistake for it, you can go and fix it. So you can divide a long program into functions, which allows you to debug the parts one at a time and then assemble them into a working whole. And well-designed functions are often useful for many programs. Once you write and debug one, you can reuse it. Something that people tend to do is once they've written a cool function for doing, fail-safe input, they'll just copy and they'll paste that function into the next program they're writing. Or you can stick all of your utility functions in a py file and then just do import and bring that in whenever you need it. Now, if you're going to do that, then give me that file as well, right? When you upload your homework, I need all the files that'll make it run, not just the one that calls your utility library. So throughout the rest of the book, we will often use a function definition to explain a concept. Part of the skill of creating and using functions is to have a function properly capture an idea, such as find the smallest value in a list of values. Later, we will show you code that finds the smallest in a list of values. All right, I don't care about what they're going to show us later. So, if you took my fundamentals class, you may have done something similar to what we're about to do now. But you know how, you've probably never done this, I don't know that I ever have, but if you take a balloon and you stuff it in a freezer, as it gets colder, the balloon contracts. And then if you take it back out and it warms up, the balloon expands. So you have a relationship between temperature and volume. Not that this is a physics class, but there's a formula that corresponds to that temperature and that volume. So as you increase the temperature, it's bigger. That's what a hot air balloon is, right? You're burning some fuel, you're generating some hot air, you're heating the temperature of the air that's inside the, and it expands. And since it expands, the density of that air is less than the density of the air around it, which generates lift and lifts it up in the air. So the formula for determining the volume of a certain amount of gas based on its temperature is this. PV is equal to nRT. All right, that's a way a lot. Pressure is measured in atmospheres. At sea level, the atmospheric pressure is 1 atmosphere. And now when you hear on the weather that the pressure is dropping and it talks about millibars or something like that, they don't measure atmospheres. The scientists do. It's kind of a metric unit. The volume is expressed in liters. N is something called moles. What moles is it's just a numeric value like dozens. I have 1 dozen eggs, well I have 1 mole of oxygen. And we'll figure out how to convert that real easily. We're going to hard code this in, make it not dependent upon which gas. because different gases have different properties. If you have a certain amount of helium or you have a certain amount of oxygen, those things differ, which is why helium can float, has a stronger, higher, liftability. Okay, and then R is a constant, is a mathematical constant. And then T is the temperature. In Kelvin. What is Kelvin? It's a temperature system that starts at 0 and goes up rather than going like negative, right? So it starts at 200. What negative 273 would be in Celsius is 0 in Kelvin. And then what is 0 in Celsius is 273 in Kelvin. Whatever. We're just going to do some functions that write some calculations that implement this. And so what we want to know is we're going to set this equal, to 1. We're just going to assume that all of our experiments are done at sea level. We're going to set this equal to the constant because it's not anything to calculate. We'll probably ask the user, heck, we could probably set this to a constant just because we're trying to compare volume and temperature. And it might be necessary to ask the user again. We may not be able to hardwire it to a value. Or we can specify. Anyways, so looks to me like we're going to need to ask the user for 3 things. We're going to need to ask them for how much of a gas we have and what temperature it's at. And based on those things, we should be able to calculate the volume of it. And then if you ran it again by changing the temperature, you might see how the volume differs once we stick it in the fridge. Something like that. So that's a long explanation of what we're going to do. We're going to need some functions. Our functions are going to include grams to moles. I mentioned that N is measured in moles, where you pass in a certain number of grams and it returns a certain number of moles. Moles is just like dozens. There's a specific number that it means. Returns moles. Okay, we're going to need another function. If we have PV is equal to nRT, I'm just kind of thinking aloud, then when we do V, we're going to have to do V is equal to nRT divided by P. So let's do one called Calc Volume that takes the number of moles and the temperature. That's probably enough. Okay, so in order to calculate moles, you just divide the number of grams, like of oxygen, by a magic number called the molar mass. You don't care what that is, but what I'm going to do is I'm going to say moles is equal to grams divided by 32 if it's oxygen, if it is O2. If it's something else, if it's nitrogen, it's a different number. And if it's carbon dioxide, if it's a different number. So that'll be the key portion of our grams to moles function. And we have a calculate volume one, which is going to run on this equation, V is equal to nRT divided by P. And remember, we're going to have to put asterisks between everything because, unlike a textbook, it doesn't multiply things together just because they're standing next to each other. And so we're going to treat R as though it's 0.0821. And we're going to treat P as though it's 1 atmosphere of pressure, like we're at sea level. And we need to decide how we want to measure temperature. Do we want to measure temperature in Kelvin? Do we want to say, okay, it's at 373 degrees? Do we want to do it in Celsius? Do we want to do it in Fahrenheit? Well, let's make this in temperature C and do the conversion on the fly. And so the conversion on the fly is that temperature is going to be equal to temperature C plus 273. That's roughly how you convert Celsius to Kelvin. And I'm going to put a comment here. And I am going to wind up typing all this stuff again into the code. Convert C to K. And so I shouldn't be putting the comments here. This is a magic number. I forget the name of it. R is constant. Okay. And then what are we going to do? We're going to input the grams of gas. We're going to input the temperature, calculate the volume. You know, if we filled up a balloon with that much, air, then that much grams of oxygen at a certain degree. How big would the balloon get? You have 2-liter bottles or whatever. Okay, that's about enough, I think. I'm going to want these two features, these two functions. So I'm going to crank up idle. I'm going to kind of flesh out my program. Just put some comments out here first. This is going to be grams to moles. And then later on, I'm going to have a calc volume function. Then we're going to ask the user for grams of O2, pure oxygen. We're going to ask the user for the temperature in C. If I was writing this in pseudocode, I'd probably just put input O2 and input temperature in C. All right, and then we're going to calculate volume, and then we're going to display volume, which is going to be in liters. All right, so let me do a save as so that I can start saving all this stuff. Are we in Lecture G? Wow, time flies. This is, by the way, known as the ideal gas law, PEV equals nRT. All right, and now when you go and take chemistry, you're going to be one ahead of everybody else. Yeah. All right, let's write a function. What's the keyword that defines functions? Def. Yep, def grams to moles. Now it's kind of dumb to hard code it to 32. We might want to ask the user what kind of gas they have because that number changes from gas to gas. I'm going to leave it at 32. Just for testing purposes. We could modify this if we ever wanted to. So as parameters, it's going to take the number of grams. We'll have to provide one argument for it. What are you? Okay. And this is just that formula that I have over here. Moles is equal to grams divided by 32, return moles. And my formula down here is a little bit wrong in as here I'm calling it in, here I'm calling it moles. I'm going to need to change that word to moles. I'm going to go back and do that while I'm still remembering it. Okay, so we've written one function. Let's write another function. Define calc volume, which takes two. Takes the moles of gas gallons or, you know, dozens or whatever, followed by temperature measured in C. Remember that every function definition has to end in a colon, and in fact, every time you start indenting, there better be a colon on the line above it. So T, our temperature, is equal to temp C plus 273 dot, I think it's 1.5 if we want to be more precise. So why not make it 1.5? And then P is equal to 1. I'm just going to put a comment here, 1 atmosphere. And I should have put a comment here, temperature in K, temperature Kelvin. Oops. Come on. And then R is equal to that. And again, I kind of rounded that constant because I don't remember it more precise than that. 0.0821. B is equal to moles times R times T divided by P. And we're going to return the volume. And I think just to be awesome, we're going to go ahead and do that if underscore underscore name equals underscore underscore main business. So if, and remember it's 2 underscores on each side, underscore underscore name, underscore underscore equals, quote, under main, under, end quote, colon. We're going to do these things. Input the user. We're going to input the grams. We're going to input the temperature. We're going to calculate the volume and display it. Alrighty. You know what I'm going to do though, just to make sure I don't have any syntax errors at this point, I'm going to add a print done and just compile and run it. It's not going to do a darn thing except print done, but it should chase out any syntax errors. Okay, I feel good about that. Now wave your hands frantically if you're getting syntax errors and you want me to come help. All right, I hear lots of typing, so I don't want to scroll down too much. I'm going to scroll down a little. All right, so ask the user for grams of O2. Yes, sir, I'll be right there. Okay. So ask the user for grams of O2. Grams underscore O2 equals, and so since I need to do 3 things, I'm going to wind up using nested parentheses. So like float, parentheses, input, input, open parentheses, and then the message we want to display. Quote, how many grams of O2, question mark.
Professor Thompson?
Yes, sir.
Does that have to, the grams O2, does that have to be indented? Because it's in
You're absolutely right. This would not work. All the program would do would print done. Well, actually, the program would run, but it would do something stupid, which is that if we did an import, it would trigger it all. This should be tabbed over. And to remind myself of that, thank you for catching that, because I would have gotten confused later. I'm going to highlight all 4 of those things, hit the tab key just to get that over as well. I am so thankful you said that. Okay. And I like putting a space in my input so that, you know, there's room after the question mark before you answer. And then an end quote, and then an end parentheses, and another end parentheses. Note that there are 2 parentheses. Why? Because we had 2 opening parentheses. You have to have 2 closing parentheses. Alrighty, now temp underscore C. Same business. In fact, to save time, I'm going to copy all that and just change the string inside it. Control C. So temp C equals, all I did is copy and paste that, speed things up. But instead of saying how many grams, we're going to say what is the temperature in C, question mark. I've got an underscore C, or I could have called it that. Either one is good. I put an underscore there, so I just put one there to be consistent. There was really no other reason for me to choose one over the other. Up here is inside a function, and we, good point, good point. Well, run with me on this one, and then I'll try to explain it. I'm glad you pointed that out because that's a key point that I want to hammer in. Okay, let's make it that, temp C. Let's make it look like we expect it to need to be. All right, now we're ready to call our function. We need to call convert grams to moles, and we need to call calculate calc volume. Now, honestly, we could have put the call to grams to moles right inside calc volume if we changed this parameter to be expecting grams. Whoops, wrong. But we didn't, so here goes. Moles equals, I've already forgotten the name of my function, grams underscore 2 underscore moles, parentheses, and then this variable we came up with here, grams underscore 02. And me being super lazy and making sure I don't make a mistake, I'm just going to copy that variable, Control C it, come over here and paste it. And I need to close parentheses. I'm just going to do check module. All that does is kind of check the syntax. It doesn't do a great job of it. But, all right, it didn't generate any syntax errors. So hopefully we're good to go. When I actually run it, I'm not going to run it until I type in the next two things, which is calculate the volume and display the output. So volume is equal to, I believe I called that function calc volume. I did. Calc underscore volume, parentheses, and what do we pass in? We pass in the moles and the temperature in C. Moles, comma, temperature underscore, nope, temp, no underscore, capital C. And let's print it out. Print. At 1 atmosphere pressure, comma, that occupies, end quote, comma. Now I'm going to hit enter, but you don't have to. Volume, comma, quote, liters, end quote, end parentheses. And yeah, I could have put more of it on one line. If I'd stretched it out, why not put it all on one line then? I'll do that, just because that looks kind of alien. Alrighty, and now I'm going to put an end if right down here at the bottom so that we can kind of distinguish. And I've done something stupid. The first line of my module is what? Yeah, that's moronic. I'm going to get rid of that. Or maybe paste it down here at the bottom. I'm just going to delete it. We don't want it to print done until, you know, that's enough. I wonder if it's going to work. All right, how many grams of O2? Now, I've got memorized, just because I used to tutor chemistry, that if I typed in 32 here, and I type in 0 here, I ought to get about 22 liters. All right, 22.4. Do we need that many decimal points? No, because I used the wrong constant for R anyways. And that conversion dividing by 32 that we did isn't exactly precise. So I should have done something a little bit better here. I'm going to make a change here. So you're going to want to watch real carefully what I do when you make it. So here, I'm going to delete everything like that. And then between the words occupies and liters, I'm going to put %.2F. That's a placeholder. It's a formatted placeholder, and we need to give it a variable to print there. But when you're using formatted printing, you don't separate the values by commas, or at least the first one. You use a %sign. Okay, did you see the changes that I made? This thing's here at the end of the statement, and this is a %.2F, which means a floating point number that displays 2 decimal places, like 1.23 or 600.32, right? The places after the decimal point. So I'm going to test it one more time, and then I'm going to do walkabout, make sure everybody who's trying to get this to work can. Alrighty. So I have a 2-liter bottle. I don't know. I'd have to work backwards on that. Let's say that I have 10 grams of oxygen. And I want to figure it out what it is at 100 degrees, which is the temperature at which water boils in Celsius. And at 1 atmosphere of pressure, that occupies 9.57 liters. All right. Forgive me, but I'm going to... I don't think that's going to give me what I want. I shouldn't waste time trying to get this to work. Tell you what. What I'm trying to do is solve it backwards to figure out how many grams of air is in a 2-liter bottle. So PV is equal to nRT, 1 pressure, volume is going to be 2, and this time I'm going to be solving for N, which is moles. So doing a little bit of algebra, I need to do that. I need to put that over that. So 2 divided by R divided by T is equal to N. The temperature is going to be at Z. No, that's not going to work. Forget it. I don't care. That's something for another time. Okay, so I'm going to run it again, and I'm going to find out how much volume that those 10 liters occupy at 0 degrees. We've stuck it in the freezer, and we've lowered it to the freezing point. So I'm just going to run it again. Again, 10 grams of oxygen. Whoopsie. 10 grams of oxygen at 0 degrees occupies 7 liters. So our 9-liter balloon shrunk down to 7 liters at 0 degrees C. I really ought to be able to figure this out in my head. Nope, apparently I can't. I'm going to do trial and error. I'm going to run it again and put in 1 gram at 0 degrees C. That's 7 liters, but I want it to go up to 2. So 2 divided by 0.7 is what? 2 divided by 0.7 is 2.85. Let's just make it 2.9. Run once more. Oh, come on. 2.9 grams at 0 degrees C is about 2 liters. Okay, so in your freezer, if you freeze a bottle, your 2-liter bottle of Pepsi or whatever after you've drained it, the air inside would weigh about 2 grams. It's really not very much. But then we put that and we heat it to 100 degrees, its volume will increase. If it was a balloon, it increases to 2.78. Gets bigger. All right, so anyways, we've broken this up into functions. I'm feeling pretty good about it. Why did we put this inside this? So that we could import this from another chunk of code and then call these functions whenever we wanted to, and it wouldn't automatically run our main code. This is our main code. So pretty much that's the paradigm that we ought to be following, is we define our functions, but then we have some main code and we block it off with this if statement. And I tried to explain that in my notice, so hope it makes sense. You can always Google if underscore underscore name underscore underscore, and you'll see other programmers, explaining why you do it. All right, so we've written functions. I think, okay, here's the point that I wanted to make about temp C. I called my parameter that. So I can fill it with that. But these names do not have to match. That doesn't have to match that. I could have called this, don't make this change because I'm going to undo it, Groot equals whatever, and then as long as I change this to Groot as well, the code's going to work just as well. Why? Why don't these have to match? Because Python is a pass-by-value language, pass-by-copy language, as are most other languages, meaning that when we call Calc Volume, the value of this argument gets copied in to this variable. They're not the same variable. It's a copy of it, right? It photocopies it. And so we still have our original here, and it doesn't matter what our original is called. When we get in here, this variable holds it. Hope that makes sense. That kind of makes sense? Yeah, so I could have called it temp underscore C, and as long as I did it there as well, then it wouldn't have mattered. That's how you can get away with passing in, how you can hard code numbers. If I wanted to hard code, a temperature of 100 degrees, I could put that there. 100 certainly does not have the name temp C. Temp C gets a copy of that value. All right, I'm going to undo those things. Then I'm going to walk around and make sure everybody's trying to get it to work. Has it working? Oh, something I want to mention. I think I mentioned it once, but I think I've forgotten, which is if you miss class, you want to watch the video at home, the question is, do you have to type along with everything you see? Not necessarily. You can do this. There's the lecture video form. You can fill out the lecture video form and upload it. All you have to put is your name, which video did you watch, the date watched, did you look at the daily notes from the video, yes, no. If there are any, you're going to put yes. If there aren't any, you're going to put there weren't any. And then what did you learn from the video? Please write at least 4 sentences describing what you learned. All right, so by the time you're done with that, maybe it was easier just to type in all the code. If you can't come up with 4 sentences, come up with 3 or 2, whatever. Just prove that you watched it. And upload that. Okay, so going back to our lecture text, I think we're done with this chapter pretty much. I don't remember seeing half these words while we were scrolling through it. I guess I wasn't reading it carefully enough. But what is the body? That's the sequence of statements inside a function definition. We had several chunks, several bodies of code. That's a body. It's indented. That's a body. This is indented. That's a body. This is indented. And if we had an if statement, it has its own body, a body inside a body, kind of like Russian nesting dolls. Don't do this. I'm gonna delete it. But right, if moles is equal to 0, whatever, and then I print oops, right, like that. This stuff is also the body. It's just the body of the if loop. It's not the body of the function. Undo, 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 undo. Okay, going back to our gal. Composition. Use an expression as part of a larger expression, or as a statement as part of a larger statement. Composition is the art of taking a formula and putting it into a computer expression, in my mind. So if you Google it up and you see PV is equal to nRT, like that, to turn it into computerese, right? Which means, using multiplication symbols. If there was a big old vertical bar, instead of, a horizontal bar, a fraction, instead you'd use a division. If you needed to put parentheses, right, that's what composition is. You need to know how to use our mathematical operators in parentheses to be able to turn a formula that you see or are given into good working code that will actually work in Python. So an example of that would be the volume of a cylinder. Well, that one doesn't have any division symbols in it. That's boring. Volume of sphere. All right, 4/3 pi r cubed, right? But we want to turn that into an expression. Well, what are we going to do? Well, it doesn't require us to use any parentheses in this one, but we might want to anyways. So what I'm going to do is I'm going to say V equals, and like I said, not strictly necessary, but why not? 4 divided by 3 times pi. I could go and import math, and then I could use math.pi. I'm just going to 3.14159 times R3. How would I type R3 in this particular language? I could do R times R times R. Yep. And there's also the exponent operator, which is what? Star, star, so star, star 3. Yep. So we use composition to turn this formula into an expression that the language actually supports. Deterministic, a program that does the same thing each time it runs, given the same inputs. Well, hopefully your programs are deterministic, right? That chaos program that I had you type in, I believe that it doesn't use a random number, and so if you give it a starting number, it should generate the same sequence of numbers every time. Now, random numbers are actually deterministic, even though they're called random, but that's because they're actually pseudo-random. And pseudo-random means that they're generated by means of a formula, and then the last one dictates what the next one's going to be. Dot notation. That's when you put a dot between the module name and the function name, or the variable and the function. So, for example, when we were using turtles that one day, we did something like this. T is equal to turtle dot turtle. And it actually had to be in uppercase in the right place. And then we did something like this. T dot forward 100 pixels, like that. And then there was an import statement above that. Import turtle, right? This is the dot notation. We had to put this here. That's the name of the function. We had to put this here. That's the name of the library. We had to separate them by a colon. Also, we have some dot notation here where we have an object, a variable, followed by a dot, and then a function that's attached to that object. If we didn't want to prefix this with turtle, we could do the same thing as we could do this. From turtle, import turtle, like that. And when we did that, we wouldn't have to prefix it like that. We could just say T is equal to turtle. So if we have some function, if we have math.sign like that, and we imported it, import math, something like this. And so we have x is equal to the math sign of 3, whatever. Then if we don't want to do this math dot, we could do this. From math, import sin. And then we could type in x is equal to sin3. Right? Cleans up the syntax a little bit. On the other hand, sometimes I don't mind seeing math dot because I know that it's a math function. I know that it's not one that I wrote. I have to go and find the code. I know that it's something that came with the language or whatever. Same for seeing, turtle.turtle. It doesn't matter how many thousands of lines down in the code I am. When I see turtle.turtle, I know, okay, the first thing has to be the name of the library. And I could go and look up that library if I wanted to learn more about it. So that's what the from syntax does. Whoopsie. I guess I actually put this in my code, didn't I? I wonder if it's actually going to run without error. I meant to be putting this in a notepad. Yeah, cannot import name turtle from turtle. I've made a mistake. Well, alrighty. Well, blow me down. Alright, so import turtle t is equal. Oh, because I didn't use an uppercase. That's why. This has to match that. Let's get it to work now. And somewhere in the background, very briefly, it drew a line somewhere, probably. Anyways, I'm going to cut this and I'm going to paste this over here into our notes. This is the from library import function syntax. A fruitful function is one that does return a value. A void function is one that does not. All the functions we've written today have been fruitful functions because they have returned statements. And the flow of execution is just the order in which statements are executed when the program runs. So when our code runs, what happens first? It defines a module but doesn't run that code because it's just defining a module. It's like we're drawing a map. Here it defines another module. We're drawing another map. And then there's an if statement. And the flow of execution is jump down to the first unindented line that's not in a function, execute that. This is true, so go ahead and do that. Go ahead and do that. And then, oh, we have a function call. So the function call jumps up to that first module, executes all that stuff, comes back down, and we're done. Then we have another function call. So the next thing that happens is it jumps up here, it runs us 4 lines of code. A value gets returned, stored in there so that we can print it out. An order of execution, when we talk about loops, can be code that executes, hundreds or thousands of times. Order of execution, if it's a selection, like an if statement, means that it's conditional. If this was not true, it would not do this stuff. So when I did an import Lecture G, it would not do this stuff because it was blocked off inside this if name code. So function call is when you so-called invoke the function. You give the name of the function, and in parentheses, if the function requires parameters, if the function has parameters, then we fill in those parameters with arguments. Like grams to moles had one parameter here. It had a variable between the parentheses. That variable is called a parameter. It's what accepts the value when we invoke it. And so this function call had to provide an argument. You can make optional parameters if you want. We could just default this value to 1 if we wanted to. And then if they didn't specify a value of grams, then it would just assume that they wanted to do it for 1 gram. Now for a mathematical expression, that's kind of silly, but you can do that. So if I wanted to, I could say is equal to 1 there, and then if I called grams to moles down here, I'm going to undo all these like that. It would solve it even though I had not provided an argument, even though I had not provided a value to fill it in. It would instead use this default. Let's undo those changes now. Okay. Alrighty. What is the purpose of the DEF keyword? It is slang. That means the following code is really cool. I don't know if people use the term def anymore. Like def jam, mos def. I doubt that that's supposed to be the answer. It indicates the start of a function. Yep. Does it indicate that the following indented section of code is to be stored for later? That's also true. It means take this body of code and just tuck it away. Don't run it, just tuck it away, and then when you are invoked, then run it. It's like drawing a map. And then I hand you the map, and then I show you to go to Walmart. You look at the map. Only then are you actually going to take the series of steps that are in the map. Or I write down a recipe. The act of writing down the recipe doesn't bake the cake. But if I give you the recipe and tell you to bake the cake, that's when it happens. That's when you invoke the recipe. What will the following Python program print out? Jane, Fred, Jane. Okay, it calls Jane first, so it prints ABC. Then it calls Fred, and so it's going to print Zap. And then we call Jane again, so it prints ABC a second time. So one of these answers had better be ABC, Zap, ABC. That one. I don't feel like doing a programming exercise with this. By the way, in my payroll assignment, one of the formulas I gave you was wrong. I don't care if you turned it in with the wrong one, right? Because it's not your fault. I'm not going to test it to make sure that you get the correct value. I'm just going to test it to make sure that it runs, you know, according to whatever. But if you haven't done that assignment yet, then the instructions are fixed. And if you really care, you could look at the instructions, compare the formula that is there now against what you have. I think it was, I listed two different formulas, A and B. I think it was A that had the mistake in it. All righty, that's about enough of that. Yes, sir.
For the assignments, always put the turn into the program or the screenshots of the program?
I like both. If the code, excuse me, if the assignment only says screenshot, then that's all you need to do. Like if you're typing in something from the book, just take a screenshot of it, because it's not like I'm going to open it up and find your syntax errors in it or whatever, because you got it working. But if it's homework that you write because I asked you to write rather than type in from the book, yes, I want the code.
Should I go back and turn in the program with my screenshots thing, because I don't got my screenshots?
I would like you to, but if you can't find them, that's okay. I'll take what you got and then just from here on out.
Okay.
Okay. All right, end of chapter 4. Iterations. In other words, looping. So, the good old while statement. Oh, by the way, the homework statement, excuse me, statements. The homework exercises for chapters up through 8 have been posted. So, we only had chapters 1 through 3 posted right now. I was trying to get us to do them at the rate of 1 a week. However, for chapters 4, 5, 6, and 7, and 8, I believe I gave us 2 weeks per chapter. That doesn't mean that I want you to go slowly. I'd rather you kind of work through them as fast as possible until you get to stuff that you don't understand. But relax the pace a little bit, but if I'm correct, then, and if I have spaced it out correctly, then we'll have the entire month of November to do other cool stuff, like creating graphical user interfaces or working on JavaScript. So that's my goal for that. And it could be that we're going to go through all the lectures and finish the lectures before we have finished the chapter homework, in which case we will move on to those interesting topics even before October 31. And so what would we use JavaScript for? To make interactive web pages. You know, buttons that light up, or you know, things that fill in with a click of a button, stuff like that. Okay, so the while is an implementation of a loop. And if you've taken Java and not Python, and you remember using a do loop, Python doesn't have those. So just jettison that little bit of information as far as Python is concerned. And the way it works is you have a condition here, a Boolean expression. And as long as this expression is true, then it will repeat that code. It's kind of like an if statement. If n is greater than 0, print n equals n minus 1. But if it was an if statement, then it wouldn't come back and check it again. It would just do this stuff, and then it would print blast off. But since it's a while, it does those things, and then it runs back up to the top, checks it again, and then and only then does it go down here. Now, in olden days, before we had cool languages, that would have been implemented with something like this. Kind of like this is going to be written in some simulation of the basic language used in the 70s. Let n equals 5, 20, print n, 30, n equals n minus 1, 40. If n greater than 0, go to 20, 50, print blast off. I know that last statement is not basic syntax, but the rest of this is pretty close. Okay. This code here and this code do the same thing, except the BASIC did not support, in its earliest implementation, a looping structure. And so you simulated looping with goto. Now, almost no language anymore, modern languages tend not to support goto because they make for very complex code. You know, you could have 200 lines of code, and then this statement could say go to line 75, right? And then the line after 75 could say go to 300. And it's called spaghetti code. It's very difficult to figure out what it's doing. So people did away with gotos for the most part and have replaced them with structures like while loops. But this would do the same thing. We set n equal to 5, we print it out, we subtract 1 from it, and if it's still greater than 0, we repeat it. We print out n, we subtract 1 from it again. So this code is going to run until n, this expression, is no longer true. So once n finally hits 0, it will not enter that body of code again. It'll be done, it'll print blast off. So the body of the loop needs to do one or two things. One is that it better change this condition so that this eventually turns false, or it better have a break or a return statement in it. Now I'm going to go back and focus on the first one. If we never changed n, then the code would run forever. That's what's known as an infinite loop. And by forever, I mean until you close the window, right? N is equal to 5, while n is greater than 0. Is n greater than 0? Yeah, sure is, because it's 5. So print it out. But say this was gone. That line would be commented out or deleted. It'd come back up and check. Yep, n is still greater than 0. It printed again. Yep, n is still greater than 0. You can see that it would just run forever. So your code has to modify the values involved so that this expression can turn false. If this expression can never turn false, it's an infinite loop. However, there are ways of bailing out of loops other than changing that condition to false. And those are return statements and break statements. And a return statement is just like what we've seen in our code here. Let's mess with return. No, let's not. Just accept the fact that if we had a return, yeah, we better type it in just to hammer the point in. We probably ought to make new code so that we're not doing all this every single time. So I'm going to do new file. I'm going to save it as Lecture G2. I already have a G2 that I accidentally created. If you do too, you can override it or whatever. Or call it something else. All right. And so I'm going to write a function called hello. And it's going to have a loop in it. N is equal to 0 while n is less than 5, colon, print, parentheses n, and that's enough, so I'm going to backspace all the way out, although I'm going to add a couple of comments. This is going to say end while. Not necessary, but comments are nice, and that's enough. Okay, so now in my main code, I'm going to call hello. And then I'm going to print, quote, done. Now, why did I say hello if I'm just going to print out n? I don't know. We should give it a better name than hello, but I didn't, so I'm going to run it. Invalid syntax. What did I do wrong there? Anybody spot the error?
Just variable, a variable against.
Yeah, this needs to be an expression. I forgot to actually put the variable in there. So I need to make it say while n is less than 5. And look what it's doing. That's an infinite loop. What did I forget now? I forgot to modify the value. Yeah, via either an input or by incrementing. So n equals n plus 1. Or I'm going to shorten that to n plus equals 1. Now when you type plus equals, don't put a space between those two. It's not plus space equals. It's just plus equals. So now it prints 0, 1, 2, 3, 4, and it stops. Well, great. What if I wanted to leave that loop early for some reason? I could put a return statement in there. Something like this. If n is equal to 3, return. That's going to cause it to exit the while loop. It will return back to the calling code. It'll come down here and print done. And that's what it did. It printed out 0, 1, 2. It didn't get to print 3 because I returned out of it. Now, if this was in the main code, I could not use a return statement. You can't use a return inside your main block of code. But if you put all your main code in a main function, like I've illustrated before, you can. So it's not a bad thing to do. The other thing you could do is you could use an exit function. An exit function just kills the program at that point. I don't see any need to really discuss that at this point. We'll probably hit it at a later point. The other thing we could do is use a break statement to get out of the while loop. We'll hit on that another time. Break statements are useful. So one form of iteration is the while statement. That implies that there are other forms of iteration. There's the for statement. And you can almost read the while statement as if it were in English. While n is greater than 0, do some stuff. Print n and then subtract 1 from it. So an infinite loop. An endless source of amusement for programmers is the observation that the direction on the shampoo, lather, rinse, repeat, are an infinite loop. You'll stand there in the shower and you'll wash your hair forever because it keeps telling you to lather and rinse and repeat. All right, that's funny. That's real funny. But I've made the joke before. So, an infinite loop and break. If you don't know how many iterations there need to be until you get halfway through the body, you might want to write an infinite loop on purpose and then use break to bail out of it. So for example, if you put while true rather than something like while n is less than 5, it's supposed to repeat forever. So if we had this, it would count down from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and keep going. It would go all the way down into the negatives. And we can kind of prove that. I'm going to delete all this stuff. Maybe I'll write it again. Def H2. We're going to set n equals to 10, and while true, colon, print n, and then subtract 1 from n. So n minus equals 1. No space between the minus and the equals. Then I'm going to add my end while comment. That makes me feel good. If you're writing nested loops, or if statements nested in loops or vice versa, then adding these little end comments can actually make the code easier to read and modify. Old habit. One that I recommend you get into. So why didn't you put an end if there? And it was only 1 line of code. That's my only excuse. Alright, so if I'm going to actually test that out, I need to do H2 down here. I need to add this line of code. So I just added that. Don't put these. Just showing you what I just added in order to invoke H2. And when I run it, it's going to be another infinite loop. It's going to count down forever because there was nothing stopping it. But we can make it stop. We could say if n is equal to 0, break. Let's see if that's what the author suggests. Nope, they don't show it. So, I'm going to do it. After we've subtracted 1 from it, if the result is 0, if n equals 0 colon, break. That says exit out of the loop. But don't return. The return happens way down here when the module is done. There's an effective return statement right here. I'm not going to put it. I'm going to type it and then delete it. There's an effective return statement there. So, the break doesn't cause a return right then and there like it did. It just keeps going. And it would continue to execute any code after the while loop until it hit the end of the module. So now it should just print down 10 do 1. Yeah. So it used break to get out of it early. Now that's kind of dumb because I would have just written this while n is greater than 0 and not had this extra logic in there. So why did we take the time to demonstrate it? Because if the calculation, if you don't know how many terms it's going to run, like you're going to ask the user enter score or -1 to quit, then you could check. And if score equals -1, then you could break out of the loop. Rather than write a while condition, you could just do while true, do some calculations, ask the user if they want to continue, and if they don't, then you can break out of the loop. And there are other ways of writing loops. You can just about always write loops in such a way that you don't have to use a break statement, but this is a very common programming paradigm that a lot of the books don't teach you. But it's one that I tend to fall back on. Otherwise, if you remember from fundamentals, there was something called the priming read. And you can avoid the so-called priming read by using a break statement and an if statement instead. Ooh, it's time to go. Alrighty.